Now, in this lecture, we will find the radius of the semicircle. In the drawing, we have triangle ABC. We know that this angle ABC equals to 90 degrees. We also know that side AB equals to 3 units. So here, side AB equals to 3 units. Side DC, or line segment DC, equals to 1 unit. And we want to find out the radius of this red semicircle. We also know that side AB is tangent to the red circle at point B, and and side AC is tangent to the semicircle at this point E. Okay, so first of all, I will present to you a new rule number 1, or the two tangents theorem. So actually, the two tangents theorem states that the lengths of two tangents from a common external point to a circle are equal. So I'll read the two tangents theorem again, or rule number 1. According to two tangents theorem, the length of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 1, or two tangents theorem? Actually, the meaning of rule number 1 is that if you have this circle and you also have this point P. Point P is an external point of this circle, because point P is not located inside this black circle nor on this black circle, but it's outside this black circle. Therefore, it is defined as external point of this circle. So if from the external point P of the circle we will draw two tangents to this black circle, so here it will be the first tangent, we define the touching point between the first tangent and this black circle as point A, and we will also draw a second tangent to this circle. And we define the touching point between the second tangent in the circle as point B. Actually, the length of the first tangent is PA. The length of the second tangent is PB. And according rule number 1 or two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. So we have here two tangents from the external common point, point P, to this black circle, and according to rule number 1, the lengths of those two tangents are equal. That is to say, PA equal to PB. Okay, so whenever you draw two tangents from an external point of a circle to that circle, then the lengths of those two tangents will be equal to each other. In this case, PA equals to PB. Okay? So we can actually implement rule number 1 in our drawing, because in our drawing we have this external point A. Point A is an external point in relation to this red semicircle, and from the external point, point A, from this point A, we have two tangents to this red semicircle. The first tangent is AB, its length is 3 units, and the second tangent is AE. And according to rule number 1 or two tangents theorem, AB equals to AE. Because of the fact that from the external point, a common external point A, we have two tangents to this semicircle, then the lengths of those two tangents are equal to each other. That is to say, AB equals to AE. But we know that AB equals to 3 units. It is given us in the question. So from this equality, we will derive that AE also equals to 3 units. So line segment AE equals to 3 units. Okay. So in the next step, I will present to you a new rule number 2, and we will implement the rule in our drawing. So rule number 2 states that a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So I'll read rule number 2 again. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if you have this circle and the center of this circle is at this point, point O, and we also have a tangent to this circle actually AB is tangent to this black circle at this point. We define the touching point between tangent AB and the black circle as point M. Actually, point M is the point of tangency of tangent AB with this black circle. Point of tangency of tangent AB with this black circle, and we also have radius from point O, the center of the circle, to point M. OM is the radius of this circle, that is to say it equals to R, the radius of this black circle. Then according to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So the tangent AB is perpendicular to this radius OM. Why? Because this radius is drawn to the point of tangency. I'll repeat again, this radius OM is drawn to the point of tangency, that is to say it is drawn to point M, that is the point of tangency. Therefore, the tangent AB is perpendicular to this radius, that is to say this angle equals to 90 degrees, and this angle also equals to 90 degrees. So whenever you have a radius that is drawn to the point of tangency, like in this drawing, then the tangent will be perpendicular to this radius. In this case, the tangent AB is perpendicular to radius OM, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. And we can actually implement rule number 2 in our drawing. In our drawing, first of all, we will define the center of this red semicircle as point O, and actually line segment BO is the radius of this red semicircle because of the fact that it starts from the center of the semicircle and ends at point B, that is a point on the semicircle itself. Therefore, line segment OB is the radius of this semicircle, that is to say it equals to R. Actually, we define R as the radius of this semicircle. Therefore, OB will be equal to R. It is the radius of this semicircle. And also, likewise, OD, for the same reason, will be the radius of this semicircle because it starts from the center of the semicircle and ends at point D, that is a point on the semicircle itself. Therefore, OD is the radius of this semicircle, that is to say it equals to R. In the next step, we will join points E and O together by a straight line. Actually, OE is also the radius of this red semicircle for the same reason, because it starts from the center of the semicircle and ends at point E. That is a point on the semicircle itself. Therefore, OE is the radius of this semicircle, that is to say it equals to R. So here we have, and we also know that AC, side AC or tangent AC is tangent to this red semicircle at point E. Point E is the point of tangency, of tangent AC with the red semicircle. And as you can see from the drawing, this radius, the radius OE, is drawn. The radius OE is drawn to the point of tangency. Therefore, according to rule number 2, the tangent AC will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle also will be equal to 90 degrees. So, actually, angle OEC is a right angle, it equals to 90 degrees. Therefore, triangle OEC is a right angle. Okay, so this triangle, the green triangle, is a right triangle. Okay. Triangle OEC, the green triangle, is a right triangle because it has one angle that equals to 90 degrees. So we will focus on the green triangle, triangle OEC. Okay. So in triangle OEC, according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse of the green right triangle is this side OC, because of the fact that side OC is in front of this right angle. Therefore, it is the hypotenuse of triangle OEC. So the square of the hypotenuse is OC square. And according to the Pythagoras theorem, it equals to the sum of the squares of the perpendiculars. That is to say, it equals to OE square plus EC square. So, I will repeat again. The green right triangle, triangle OEC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OC square equals to OE square plus EC square. But what is the value of OC? So you can see from the drawing, OC equals to R plus 1. So if OC equals to R plus 1, then OC square will be equal to R plus 1 square. Again, OC square equals to R plus 1 square, and it equals to OE square. OE is R, the radius of the semicircle, so OE square will be equal to R square, and we will define side EC of the green triangle as X, that is to say EC equals to X units in its size. So if EC equals to X, then EC square will be equal to X square. So in total we got that R plus 1 square equals to R square plus X square. Here we will open the brackets in this side of equation number 1, and we will get that R plus 1 square equals to R square plus 1 plus 2R according to the algebraic identity that A plus B square equals to A square plus B square plus 2 times AB. So R plus 1 square will be equal to R square plus 1 plus 2R, and it equals to R square plus X square. Okay, so here we have R square in both sides of equation number 1. So we will subtract R square from equation number 1. So R square will get cancelled. And what is left after we cancelled R square? What is left, it is actually 1 plus 2R equals to X square. So according to equation number 1, we found out that 1 plus 2R equals to X square. Okay? So in the next step, we will focus on the right triangle ABC, the right big triangle ABC, and we will also focus on the small green right triangle OEC. Okay, so we focus on triangle ABC, the right big triangle, and the green small right triangle OEC. And we will actually prove that those two triangles are similar to each other. So I will repeat again. We will focus on triangle ABC and on triangle OEC. Okay? First of all, we know that those two angles are equal to each other. They are both right angles. So angle ABC of triangle ABC, this angle equals to angle OEC of triangle OEC, this angle, and they are both equal to 90 degrees. They are both right angles. So angle ABC equals to angle OEC, and both angles are equal to 90 degrees. They are right angles. Actually, this angle, angle C, is a common angle. It belongs to both triangles. Therefore, we can write down that angle C equals to angle C. It's a common angle that belongs to both triangles. Okay, angle C equals to angle C. It is a common angle that belongs to both triangles. And actually, those two angles are also equal to each other according to third angle theorem. So, this angle, angle BAC of triangle ABC, equals to this angle, angle EOC of triangle EOC, according to third angle theorem. I will repeat again. Angle BAC of triangle ABC equals to angle EOC of triangle EOC according to third angle theorem. So, what is third angle theorem? Third angle theorem states that, or rule number 3 also. So, rule number 3 of third angle theorem So according to rule number 3 of third angle theorem, if two angles of one triangle congruent to two angles of another triangle, then the third pair of angles must also congruent. So I will write rule number 3 of third angle theorem again. According to third angle theorem, if two angles of one triangle congruent to two angles of another triangle, then the first pair of angles must also congruent. So what is the meaning of rule number 3 of third angle theorem? The meaning of third angle theorem is that if we have two triangles, triangle ABC so this is triangle ABC, and we also have triangle DEF. This is triangle DEF. And we actually know that those two triangles has two pairs of angles that congruent. The first pair of angles that congruent is alpha equals to alpha. This is the first pair of angles that congruent. Then we have second pair of angles that congruent here, beta equals to beta. Suppose that this angle is theta or gamma, and this angle is theta. Then, according to rule number 3 of third angle theorem, if this is the situation, that we know that those two triangles has two pairs of angles that congruent. The first pair is alpha, and the second pair is beta. Then, according to third angle theorem or rule number 3, the first pair of angles also must congruent. That is to say, angle gamma must equal to angle theta. Angle gamma must be equal to angle theta. So we actually will prove that third angle theorem is true. We will prove that angle gamma equals to angle theta. That is to say, we will prove that the first pair of angles congruent or equal to each other. We will rely on the sentence that the sum of the angles in any triangle equals to 180 degrees. So here in triangle ABC, the sum of its angles equals to 180 degrees. That is to say, alpha plus beta plus gamma equals to 180 degrees. Likewise, in the other triangle, triangle DEF, the sum of its angles must be equal to 180 degrees. That is to say, alpha plus beta plus theta must be equal to 180 degrees. So, I will repeat again, the sum of the angles in triangle ABC must be equal to 180 degrees. This is equation number 1. And equation number 2 is that the sum of the angles in triangle DEF must be equal to 180 degrees. So here we will subtract equation number 1 from equation number 2, and we will get that alpha minus alpha is 0, beta minus beta is 0, and gamma minus theta equals to 180 degrees minus 180 degrees is 0. So in total we got that according to equation number 3, gamma minus theta equals to 0. 180 degrees minus 180 degrees is 0. Here we will add theta to this equation number 3, and we will get that angle gamma equals to angle theta, and that is exactly what we wanted to prove. We wanted to prove that the first pair of angles also congruent, when they are equal to each other, and indeed we proved that angle gamma equals to angle theta. In this way, we actually proved that the third angle theorem is true. Okay? So we will return to our original drawing. We actually proved the triangle ABC has three angles that equal to the three angles of triangle EOC. Therefore, we proved the triangle ABC is similar to triangle EOC. We proved the triangle ABC is similar to triangle OEC. According to angle similarity rule. So I will repeat again. We actually proved the triangle ABC is similar to triangle OEC according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is that if you prove that all angles of one triangle congruent or equal to all three angles of the other triangle, then you prove that those two triangles similar to each other according to angle similarity rule. And from the fact that triangle ABC is similar to the great triangle EOC, we will conclude that AB over AC in triangle ABC equals to OE over OC in triangle OEC. Okay, I'll repeat again. From the fact that triangle ABC is similar to triangle OEC, the green triangle, we will conclude that AB over AC in triangle ABC equals to OE over OC in triangle OEC. Okay. But what is the value of AB? The value of AB is given to us, it equals to 3 units. So AB equals to 3. And what is the size of AC? The size of the hypotenuse OEC equals to, according to the drawing, 3 plus x. 3 plus x. So actually found out that AB equals to 3 units, AC equals to 3 plus X, and it equals to OE. As you can see from the drawing, OE is the radius of the semicircle, that is to say it equals to R. And what is OC? OC, according to the drawing, as you can see from the drawing, it equals to R plus 1. I will repeat again. OE equals to R and OC equals to R plus 1. In total we got that 3 over 3 plus X equals to R over R plus 1. Here we will cross multiply equation number 2 and we will get that 3 times R plus 1 equals to R times 3 plus X. After we cross multiply this equation and equation number 2, we got this to this expression that 3 times R plus 1 equals to R plus times 3 plus X. Here we will open the brackets in both sides of equation number 2 and we will get that 3R plus 3 equals to 3R plus R times X. So after we open the brackets in this equation number 2, we got this expression that 3R plus 3 equals to 3R plus Rx. Here we will subtract 3R from equation number 2. We have 3R in both equations, so we will subtract 3R from equation number 2, so 3R will get cancelled. And what is left after we cancel 3R? What is left? It is actually 3 equals to R times X here we will divide equation number 2, this equation, by X. Why it is allowable to divide by X? Because of the fact that X is the side of the green triangle OEC. It must be a positive number, so it can never be 0. Therefore, it is allowable to divide equation number 2 by X. So we will divide equation number 2 by X and we will get that the radius of the semicircle equals to 3 over X. Okay? We found out that according to equation number 2, the radius of the semicircle equals to 3 over X. But we have already found out that according to equation number 1, 1 plus 2R equals to X squared. So here we will substitute R in this equation number 1 by 3 over X, because R equals to 3 over X. And we will get that 1 plus 2 times R, and R is 3 over X according to equation number 2. And it equals to X squared. Okay, so here 2 times 3 is 6, so we will get that according to equation number 1, 1 plus 6 over x equals to x squared. We got that 1 plus 3 over x equals to x squared. Here we will multiply equation number 1 by x, this equation, and we will get that x times 1 is x over x, 6 over x times x is 6, x squared times x is x cubed, so in total we got that x plus 6 equals to x cubed. We will subtract x from equation number 1 and we will get that x cubed minus x equals to 6. Here we will subtract 6 from equation number 1 and we will get that x cubed minus x minus 6 equals to 0. So here we know that minus 2x squared plus 2x squared is 0. And we can add 0 to any equation, so we will add this expression that equals to 0 to equation number 1. I will repeat again that we can add 0 to any equation, so it is allowable. So we will get that x cubed minus 2x squared plus 2x squared that equals to 0 minus x minus 6 equals to 0. Okay, so here we will substitute minus x by minus 4x plus 3x equals to minus x, so we will substitute minus x by minus 4x plus 3x. Okay, and we will get that x cubed minus 2x squared plus 2x squared, and instead of minus x we will write down minus 4x plus 3x minus 6 equals to 0. So in total we got this equation number 1. So here we will divide the equation number 1 to 3 parts and we will take a common factor from each part. So actually this will be the first part. This expression will be the second part that we will take a common factor from it, and this will be the third part that we will take a common factor from it. So we start from the first part. The first part is x cubed minus 2x squared. Here we will take a common factor of x squared from this expression. So what is left from x cubed after we took a common factor of x squared? What is left? It is actually x. And what is left from minus 2x squared after we took x squared as a common factor? What is left? It is actually minus 2. So in total we got that x cubed minus 2x squared equals to x squared times x minus 2. We'll do the same process for the second expression. We have the expression of 2x squared minus 4x. Okay, so the second expression is 2x squared minus 4x. The common factor that we will take from this expression, the second expression, will be 2x. And what is left from 2x squared after we took from it 2x as a common factor? What is left? It is actually x. And what is left from minus 4x after we took from it 2x as a common factor? What is left? It is actually minus 2. So in total we got that 2x squared minus 4x equals to 2x times x minus 2. We will repeat on the same process for the third expression. The third expression is 3x minus 6. And the common factor that we will take from 3x minus 6 is 3. So what is left from 3x after we took a common factor of 3? From it, what is left? It is actually x. And what is left from minus 6 after we took from it 3 as a common factor? What is left? It is actually minus 2. So in total we got that 3x minus 6 equals to 3 times x minus 2. So in the next step we will substitute expression number 1, 2 and 3 by their equalities. Okay, and we know that the sum of those three expressions equal to 0. So we will get that we will substitute x cubed minus 2x squared by x squared times x minus 2, and we will substitute 2x squared minus 4x by 2x times x minus 2, and we will substitute 3x minus 6 by 3 times x minus 2. And we know that the sum of those two expressions equals to 0 according to equation number 1. So in total we got this equation number 1. So here we will take a common factor of x minus 2 from this equation number 1, and we will get that so x minus 2 is a common factor. So what is left from this expression after we took x minus 2 as a common factor? What is left? It is actually x squared. And what is left from 2x times x minus 2 after we took from it a common factor of x minus 2? What is left? It is actually 2x. And what is left from 3 times x minus 2 after we took x minus 2 is a common factor? What is left? It is actually 3. And it equals to 0. So in total we got this equation number 1, x minus 2 times x squared plus 2x plus 3 equals to 0. Here we will have two possible solutions to this equation. The first solution is x minus 2 equals to 0, and if x minus 2 equals to 0, then no matter with what we will multiply it, it will 0 this side of the equation. So the first solution is that x minus 2 equals to 0. The first solution to equation number 1, x minus 2 equals to 0. And the second solution to this equation number 1 is that the quadratic equation x squared plus 2x plus 3 equals to 0. X squared plus 2x plus 3 equals to 0. So this is actually a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. When a, b, and c are the coefficients of this general quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula. The special formula is that x equals to minus b plus minus square root of b squared minus 4 times a times c over 2 times a. So we will use this formula in order to find out the value of x. Okay, so in our specific quadratic equation, the coefficients of this specific quadratic equation, x squared plus 2x plus 3 equals to 0, are as follows: a equals to 1, b equals to 2, and c equals to 3. So we have all the data that is needed in order to find out the value of x. So we will put the data inside this formula and we will find out the value of x. So we will get that x equals to minus b. B is 2, so minus b is minus 2, plus minus square root of b squared. B is 2, so b squared is 4, minus 4 times a times c. So minus 4 times a is 1, times c times 3. Okay, over 2 times a, and a is 1, so over 2. Okay. So we got here that x equals to minus 2 plus minus square root of 4 minus 4 times 1 is 4, and 4 times 3 is 12. So it is 4 minus 12 over 2, or x equals to minus 2 plus minus 4 minus 12 is minus 8 over 2. So here minus 8 is a negative number and it doesn't have a root. Therefore, the quadratic equation x squared plus 2x plus 3 doesn't have a solution. So we will cancel this possibility and we left only with the solution that x minus 2 equals to 0. Okay, so actually if x minus 2 equals to 0, if x minus 2 equals to 0, then x equals to 2. So we found out that x equals to 2, but according to equation number 2, we already found out that the radius of the semicircle equals to 3 over x. So we will put the value of x inside this equation and we find out the radius of the semicircle. So the radius of the semicircle will be equal to 3 over x, and x is 2. So the radius of the semicircle r equals to 3 over 2 units, or we can represent it as 1.5 units. Okay? So I will repeat again. The radius of the semicircle equals to 3 over 2 units, so 1.5 units. Here, the radius of this semicircle, the red semicircle, r, equals to either 3 over 2 units or 1.5 units. Okay, so now I'll summarize the lecture. Actually, we wanted to find out the radius of this semicircle. We have triangle ABC. It is a right triangle. Angle ABC equals to 90 degrees. Side AB equals to 3 units. Line segment DC equals to 1 unit. And we want to find out the value of the radius of the red semicircle. So first of all, I presented to you rule number 1. According to rule number 1, or two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 1? The meaning of rule number 1 is that if we have this circle and we have external point P, and from point P we will draw two tangents. This is the first tangent, this is the second tangent. The length of the first tangent is PA and the length of the second tangent is PB. According to two tangent theorem or rule number 1, the lengths of two tangents from a common external point to a circle are equal. So the length of those two tangents that exit from the common external point P to this black circle, the lengths of those two tangents are equal to each other. That is to say, PA equals to PB. Okay? Because the length of the first tangent is PA. The length of the second tangent is PB. And according to rule number 1 or two tangents theorem, the length of those two tangents that exit from the external point, common external point P, are equal to each other. That is to say, PA equals to PB. Okay? That is the meaning of rule number 1. And we actually implemented rule number 1 in our drawing. In our drawing, we have the external point A, and from the external point A, we have two tangents. The first tangent is tangent AB, its length. The length of tangent AB is 3 units, and we also have tangent AC is tangent to this circle is point E, or the tangent AE is the second tangent, and according to rule number 1 or two tangent theorem, AB equals to AE, but we know that AB equals to 3 units, therefore we got this equality, and from this equality we we derive that AE also equals to 3 units. Line segment AE also equals to 3 units. And then I presented to you rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its points of tangency. So, what is the meaning of rule number 2? The meaning of rule number 2 is that if we have this circle and the tangent AB is tangent to this black circle at point M is the point of tangency, then according to rule number 2, a tangent to a circle, that is to say a tangent AB, is perpendicular to the radius drawn to its point of tangency. So because of the fact that this radius, the radius OM, is drawn to the point of tangency, that is to say it is drawn to point M, that is the point of tangency, then the tangent AB will be perpendicular to this radius, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay, so this is the meaning of rule number 2, and we actually implemented rule number 2 in our drawing. In our drawing, we have tangent AC is tangent to this semicircle at point E. Point E is the point of tangency, and we have the radius OE that is drawn to the point of tangency, that is to say it is drawn to point E. Therefore, the tangent AC will be perpendicular to this radius. That is to say this angle will be equal to 90 degrees and this angle also will be equal to 90 degrees. And because of the fact that angle OEC equals to 90 degrees, then the green triangle, triangle OEC, is the right triangle. So we can implement the Pythagoras theorem in the right triangle, triangle OEC, according to the Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say OC square equals to OE square plus EC square. As you can see from the drawing, OC equals to R plus 1 and EC OE equals to R and EC equals to X. Therefore, OC square will be equal to R plus 1 square, OE square equals to R square, and EC square equals to X square. We open the brackets in equation number 1 in this side of the equation number 1, and we got that R plus 1 square equals to R square plus 1 plus 2R, and it equals to R square plus X square. Here we subtracted R square from equation number 1, and we got that according to equation number 1, 1 plus 2R equals to X square. Okay? Then we focus on the right triangle, triangle ABC, and on the right triangle, triangle OEC, and we proved that those two right triangles are similar to each other. First of all, we have those two angles that are equal to each other. They are both right angles. That is to say, angle ABC equals to angle OEC equals to 90 degrees. And we also have this angle, that is a common angle. It belongs to both triangles, to triangle ABC and to the green triangle, triangle OEC. So we can write down that angle C equals to angle C. It's a common angle that belongs to both triangles. And we also have those two angles that are equal to each other according to third angle theorem. That is to say, angle BAC equals to angle EOC according to third angle theorem. So what is third angle theorem? Third angle theorem is that states that, or rule number 3 also. So according to third angle theorem, if two angles of one triangle congruent to two angles of another triangle, then the third pair of angles must also congruent. So what is the meaning of rule number 3 or third angle theorem? The meaning of third angle theorem is that if we have two triangles, triangle ABC and triangle DEF, those two triangles have two pairs of angles that congruent. This is the first pair of angles that congruent to each other, they are both equal to alpha. And this is the second pair of angles that are congruent to each other, they are both equal to beta. So if this is the situation, then according to third angle theorem, the third pair of angles must also congruent, that is to say angle gamma must be equal to angle theta. And we actually proved that angle gamma indeed equals to angle theta, according to the rule that the sum of the angles in any triangle equals to 180 degrees. So if we focus on triangle ABC, the sum of its angles equals to 180 degrees, that is to say alpha plus beta plus gamma equals to 180 degrees. And likewise, in triangle DEF, the sum of its angle equals to 180 degrees, that is to say alpha plus beta plus theta equals to 180 degrees in triangle DEF. So we subtracted equation number 1 from equation number 2, and we got that alpha minus alpha is 0, beta minus beta is 0, and gamma minus theta equals to 180 degrees minus 180 degrees is 0. So here we added theta to equation number 3, and we got that angle gamma equals to angle theta, and that is exactly what we wanted to prove, that the third pair of angles also equal to each other, that is to say angle gamma equals to angle theta, and that is exactly what we proved, that angle gamma equals to angle theta. Therefore we actually proved that the third angle theorem is indeed true. So we return to our original drawing. In our original drawing we actually proved that the right big triangle, triangle ABC, has three angles that congruent to the green small right triangle, triangle EOC. Therefore, we proved that triangle ABC is similar to triangle EOC, the green triangle, according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is that if you prove that all three angles of one triangle congruent to all three angles to another triangle, then you prove that those two triangles congruent to each other according to angle similarity rule. Okay, so from the fact that triangle ABC is similar to triangle OEC, we will conclude that AB over AC in triangle ABC equals to OE over OC. We will repeat again. AB over AC in triangle ABC equals to OE over OC in the green triangle, triangle OEC. What is the value of AB? AB equals to 3 units. It is given us in the question. What is the value of AC? The hypotenuse of triangle ABC. AC equals to 3 plus x. You can see it from the drawing. What is the value of OE? OE is the radius of the semicircle. And what is the value of OC? The value of OC equals to R plus 1. So in total, we got that AB over AC equals to OE over OC. It means that 3 over 3 plus x equals to R over R plus 1. Okay, here we cross multiply the equation number 2, and we got that 3 times R plus 1 equals to R times 3 plus x. Then we open the brackets in equation number 2, and we got that three R plus 3 equals to 3R plus Rx. Here we subtracted 3R from equation number 2, and we found out that 3 equals to Rx. We divided equation number 2, this equation, by x. It is allowable to divide the equation by x because x is the side of a triangle. It can never be 0, so it is allowable to divide the equation number 2 by x. So we divided equation number 2 by x, and we got that the radius of the semicircle equals to 3 over x. But we have already found out that according to equation number 1, 1 plus 2r equals to x squared. So we can substitute r in this equation number 1 by 3 over x, because r equals to 3 over x according to equation number 2. So we substituted r in equation number 1 by 3 over x, and we got that 1 plus 2 r is 3 over x equals to x squared. 2 times 3 is 6. So we got to the equation that 1 plus 6 over x equals to x squared. Here we multiplied this equation number 1 by x, and we got that x plus 6 equals to x cubed. We subtracted x from this equation number 1, and we got that x cubed minus x equals to 6, and we subtracted 6 from this equation number 1, and we found out that x cubed minus x minus 6 equals to 0. Here we added the expression minus 2x squared plus 2x squared to this equation number 1. Because of the fact that this expression equals to 0, it is allowable to add 0 to any equation. So we did it, and we got this expression. Then we substituted minus x by minus 4x plus 3x, because minus 4x plus 3x equals to minus x, so we substituted minus x by minus 4x plus 3x, and we got to this expression. Then we divided this equation number 1 to 3 parts, and we took a common factor from each part. The first part is x cubed minus 2x squared. The common factor that we took from this expression is x squared, and inside the bracket what is left is x minus 2. The common factor that we took from 2x squared minus 4x is 2x, and what is left inside the bracket is x minus 2. And the common factor that we took from 3x minus 6 is 3, and what is left inside the bracket is x minus 2. So because of the fact that here we have this equality, these three equalities, we can substitute those three expressions by those three expressions because they are equal to each other. So we did it, and we got this expression, equation number 1, and in this equation number 1 we took a common factor of x minus 2 from this equation number 1, and we got, so this equation number 1, that x minus 2 times x squared plus 2x plus 3 equals to 0. Here we have two solutions that are possible. Even x minus 2 will be equal to 0, or either x squared plus 2x plus 3 will be equal to 0. So we focused on the second solution that is possible. The second solution is a quadratic equation, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. When a, b, and c are the coefficients of this general quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula, that x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. And in our specific quadratic equation, the coefficients of our specific quadratic equation, this specific quadratic equation are as follows: a equals to 1, b equals to 2, and c equals to 3. So we put the data inside this formula in order to find out the value of x, and we found out that x equals to minus b is 2, so minus b is minus 2, plus minus square root of b squared, b is 2, so b squared is 2 squared, 2 squared is 4, minus 4 times a times c, minus 4 times a is 1 and c is 3, okay, over 2a, 2 times a a is 1, so 2 times 1 is 2. Then we got that x equals to minus 2 plus minus. Here we have 4 minus 4 times 3 is 12. So we got that x equals to minus 2 plus minus square root of 4 minus 12 over 2. And 4 minus 12 is minus 8. So we got this expression that x equals to minus 2 plus minus square root of minus 8 over 2. But because of the fact that minus 8 is a negative number, and a negative number doesn't have a root. Therefore we are stuck here. That is to say, the quadratic equation x squared plus 2x plus 3 equals to 0 doesn't have a solution. Okay? Therefore, we will abandon this possibility. It is not true. We will cancel it, and we left only with the solution that x minus 2 equals to 0. So if x minus 2 equals to 0, then x equals to 2. And we have already found out that according to equation number 2, the radius of the semicircle equals to 3 over x. So we can put the value of x inside this equality, and we will find out the radius of the semicircle. Okay, we will get that the radius of the semicircle equals to 3 over x, and x is 2. And x is 2. So the radius of the semicircle equals to 3 over 2 units, or it can also represent as 1.5 units. I will repeat again. The radius of this red semicircle R equals to either 3 over 2 units, or it equals to 1.5 units. I will repeat again. The radius of this semicircle R equals to either 3 over 2 units, or it equals to 1.5 units. Okay, thank you very much.